By definition, a hyperbola is the set of all points whose distances from two fixed points, or foci, have a constant difference. So it's a very similar idea to the definition of ellipse. The difference is that we have a difference instead of a sum that's always going to have a value of 2a. You've got two options. You can have a major axis that's horizontal, or you can have a major axis that's vertical. And the equation for a hyperbola with a horizontal major axis, and so the foci are on the x-axis and the vertices are on the x-axis, is going to be x squared over a squared minus y squared over b squared equals 1. Now the way that looks, and the way I'm going to show you how to sketch graphs of hyperbolas is a little bit different from what's shown in your textbook. I like my way better. I think it's very straightforward and very, very easy. The center, of course, of these hyperbola is 0, 0. So we're still talking about the same center point here at the origin. And just like with an ellipse, you look at whatever number is under x, take the square root of that, and that's basically how wide you need to go. Instead of sketching an ellipse, we're going to draw kind of a box. It'll make sense in a minute. So from 0, 0, I'm going to count a units to the right, a units to the left. So this has the point a, 0. This point has the coordinates negative a, 0. Then looking at the value of b, since that's under y, that tells us how far up and down to count from the center. So the ordered pair for this point is 0b, 0, negative b. Now instead of drawing a curve that goes through those 2 points, what we do this time is we're going to draw a box. So bear with me while I get this set up. Okay. You draw a box that goes through these 4 points on the axes. Oops. Alright, and then I adjust my box so that it actually does what I need it to do. There we go. Okay. Then draw lines that run through the opposite corners of the box, so the lines that contain the diagonals of the rectangle. Okay. A straight edge or a little, small ruler is very helpful. Something like this. Alright, now since our hyperbola here has a horizontal major axis, the length of the major axis is still 2a, and that is still the distance between the vertices. So we're going to have a vertex at a0 and another vertex at negative a0. And then what you do to sketch your hyperbola is just use the asymptotes, okay, which are the diagonals of your box, and make sure that your curve goes through the vertex or the vertices that you've drawn, and you get your hyperbola. Alright, so what have I forgotten to tell you? Foci. In every hyperbola, it is going to be true that your foci are going to be c units away from the center point. The difference is c this time is a length greater than a. So your curve's always going to go kind of curve around your focus points. Negative c, 0. The relationship between, a and b you can pull from the equation. The relationship between a, b, and c is that b squared is c squared minus a squared. And that is different from the equation that gives you the relationship in the ellipse. With a hyperbola, c is greater than a, and they're both positive. All right, if we have an ellipse or a hyperbola, excuse me, with a vertical major axis, our process is the same. We still take a look at the number that is under y. That tells us how far up and how far down to count. So we look at the point 0a, this case, and 0, negative a. And then you look at the number that's under x, and that tells you how far to the right and to the left to count. So b0, negative b0. Draw your box. And the asymptotes. And the more accurate, the straighter and neater you can make this part of it, the better your picture looks. And then, let's see. We'll have since our major axis is vertical, then this has got to be a vertex, and this has got to be a vertex, and our hyperbola would curve around this way. The hyperbola is the only one of the conic sections, the only curve I can think of that has a single equation, but when you sketch the curve, it's got two separate parts. It's kind of interesting. Then, of course, we have a focus at 0c, and another focus at 0, negative c. Now, equations for asymptotes. All of these hyperbolas, since the center is 0, 0, you'll notice that your two asymptotes intersect at the center of the hyperbola. The textbook suggests that you just memorize the formulas. So it's positive and negative because one asymptote's positive slope, the other one's negative slope. B over A or A over B, and you have to think. You'd have to memorize which one goes with which. I would recommend that you not bother doing that. If you've done your graph the way I'm showing you to do it, then you're going to be able to figure out what the slope is by comparing the center point to one of the corners of the box that you've drawn. And just think about rise over run. Okay, in this case we have a rise of A and a run of B. So this equation is y equals A over B x. Looking at the other line, we'd have a rise of negative A and a run of B. So this equation is negative A over B times x, and you can always just figure it out that way. Now let's look at an example. We have the equation 25y squared minus 4x squared equals 100. Now that does not look like either one of the equations for the hyperbolas that I've given you. The problem is that we don't have fractions and we don't have a constant of 1 on the right side of the equation. But we can make that happen. As long as you divide everything by 100, you're legal. You're doing what you're supposed to do. Simplify your fractions. Y squared over 4 minus x squared over 25 equals 1. Okay, I know that we're going to have a vertical major axis. Oops, that's not what I want. And I know that from the center point, I would count up 2 units and down 2 units, right 5 units, and left 5 units. And we're going to draw our box that goes through those points. Drawing asymptotes next. All right. So what do we know? We know A is 2. We know B is 5. Okay, now with an ellipse, with an ellipse, a was always the bigger of the two numbers. With a hyperbola, it's not the case. A squared is always under the first term, whatever's in front, whatever the x squared or the y squared that's positive, that's always going to be over a squared. So a is 2, b is 5. I can figure out what c is by working with this equation. So 25 equals c squared minus 4. So 29 is equal to c squared, and c is the square root of 29. Now, since the hyperbola starts with y, then I know that we have to have a hyperbola that's opening up and down. So we have a vertex at 0, 2. We have a second vertex at 0, negative 2. And you can sketch the curve. This one is really, really wide. Okay, that's pretty bad, but you get the picture. And our foci, one of them would have coordinates 0, positive square root of 29, and the other would have coordinates 0, negative square root of 29. And then you'd need to look at your calculator to get a decimal approximation to put that in roughly the right place. But we might have focus F1 here, focus F2 about there. Let's see, asymptote lines. You're going to need equations for those. One's going to be positive, the other's going to be negative, and I'm thinking about comparing the center point to one of the corners of the box. That's a rise of 2 and a run of 5. So 2/5 x, positive and negative 2/5 x. So that's all the information that you'd need to have for that hyperbola. You also are going to need to be able to, if you're given some information about a hyperbola, you're going to need to be able to write the equation for it and sketch the graph. So suppose we know we have vertices of plus and minus 1 comma 0 and a hyperbola that goes through the point 5/3 8. Alright, since the vertices are positive and negative 1, 0, this is what this tells me. If I think about where those points are. So we know our hyperbola's got to open to the left and to the right. And we know the value of a right now is 1. So we're going to have x squared over 1 squared minus y squared over something equals 1. We don't know what b is yet. But we do know that our curve at least one branch of the curve goes through the point 5/3 8. So if I substitute in 5/3 for x, that gives me an equation that I can solve for b. Takes a few steps, but you will eventually get to the point where you find that b is equal to 6. So you want to make sure that you can do that algebra. But for now, what I know is that our equation would be x squared over 1 minus y squared over 36 equals 1. So that's the equation. The graph then go up to 6 and down to negative 6. I'm estimating here. This is obviously not exactly accurate. Draw your box. Wow. Okay, you definitely want to take a little more care and a little more time getting this drawn than I am. This is just a little lopsided. Alright, so I know my hyperbola's got to contain that point and use those asymptotes. Again, another really, really wide one. The other things that we might need to know about this hyperbola are the coordinates for the foci. So using the fact that b squared is equal to c squared minus a squared, I'll have 36 equals c squared minus 1. So the square root of 37 would be c. So we will have a focus at the square root of 37, 0, and another focus at negative square root of 37, 0. The asymptotes will have equations that are positive and negative. Thinking about my box now. From the center to a corner of the box, that's a rise of 6 and a run of 1. So positive and negative 6x would be the equations for the asymptotes.